All right, we're gonna get started. I'm gonna record another session, and in this session, I'm gonna try to do some refactoring on the code that we've been writing. I think uh, there were some issues in the last couple of sessions where I was trying to do something. I was trying to choose what function we were using for evaluating a position, and to do so, I needed it to sort of have access in a kind of. I had to do something kind of awkward with the object oriented structure. So I'm gonna try to refactor it so that it's not so awkward, and allows me to reuse the code for something else. So specifically, I want to use it. I have like the minimax function going, and I want that to be able to be used for quiescence search, which is a concept in chess programming where when you're done sort of doing a full search for moves, you do like a partial search where you only look at possible captures or checks or escaping from check, and that makes it so that the branching factor is a lot smaller, so you can continue searching, and you avoid these problems where you leave like a piece hanging at the end of the maximum depth that you're searching. So that's what I'm going to try to do. But to begin with, it's just going to be refactoring. I'm not sure. I don't think I'm going to. We'll see. I don't know if I'll have time to do Quiescence Search, but if refactoring goes well, we might be able to do that. Okay, so where's my? So this is the code, and the latest version. Yeah, I think the thing is, like, I have this minimax score function that's outside. It's like it's a global function, and I keep having to pass in some. Like, I have some hacks right now happening where I'm using sort heuristic as a placeholder for, I mean, this is what I'm using to calculate a score, and I have this nice function inside the score engine, which is this cache score function. I want to be able to pass that in all the time and use that as the way of looking up the score, but it doesn't do that right now. So I think my main strategy is I'm going to move minimax into the score engine class, and in fact I'll probably just call this I'll leave it as score engine. I can name I can change the name at some later point, but let's see. So we have store position, that's fine. Just a second. Okay, so we have these different methods, and we have this search method, and this is where, let's think about if we need to change this at all. So the search method, there's a couple things. I noticed in a game I was playing, or that I've had the bot play, it played some pretty weird moves. So this is the game I played against a different, I pit BirdBot against a different bot, against some JavaScript mechanical Turk bot that's like online a lot. So it's like one of the more popular bots on Lichess. And I mean, so these moves are not good. These are objectively bad moves, but they're not like terrible. I'm not straight up hanging pieces yet. But then at some point it does some like really stupid stuff. So like, I mean, this is fine. I mean, it's not good, right? Moving pawns like this is not good. But it's like, it's not obviously losing material. The random rook move is not great, but here's where things get weird. So there's some exchanges that happen. So far, again, like here, it's still, again, it's not playing well, but it's like not obviously wrong. It's like, there's a lot of tension here. But what happens, like this right here, the Turk.js takes our pawn, and I'm almost certain like there's no other move than taking back, right? You should just take back, right? There's nothing else you should do. I mean, okay, you could do an intermediate move like taking there, the threatening the knight, so then Turk.js has to do something, and then you can take this later. So you can do something like that, but instead BirdBot plays this, right? Like this can't be right. Like it seems like there's some kind of bug. This is on a rapid time control, so it could be that it just ran out of time. But even if it searches a depth 2, it should see that taking this piece should be the right move. So I feel like there's some kind of mistake. There must be some kind of mistake in my reasoning in the code. So some repair is necessary, but let me see. So one of the things I did in between streams is after last time, I wanted it. I was a little frustrated with some of the bad moves that it was making, and so I tried to fix it and perhaps introduced more bad moves. But the way I set it up was I now have it try to select randomly among all the moves that are equally good, and this came because a lot of moves in the opening when you have a minimax framework, they're all worth 0, right? Because pretty much in the opening, right, no piece can early in the opening, no piece can capture any other piece. So like pretty much you have to look ahead a lot to be able to see any differences. And yeah, so I thought maybe if there's a lot of moves that are equally good, then choose randomly among them rather than choosing like the first one you see, which is what it was doing. I thought that was the without random choice, it was probably biasing it toward however Python chess orders the moves. But anyway, so I tried to add that, so I now have a best moves list, and every single time we see a score for a position that is better than the best score, we set the best score to the current score, and then we create we empty that list and create a new list that's just the move, the current move. And then if you see that the score is equal to the best score, then you just append it. So there's going to be we'll collect a list of best possible moves, and then at the end it does random choice, right? So it takes a random choice among the best moves. It seems like it should work. I don't know why it doesn't work, but anyway, so this code looks fine. And let's see. So I have this deadline thing. So there's a time thing happening here. There is also another concern I have about the way that I did time management last stream. I have the stream. Sorry, I have the bot sort of give up on a search in the middle of a level. Right? So if it goes to depth 3 and then it starts depth 4 and then it runs out of time, it then uses the scores that are computed partially in depth 4 and partially in depth 3, and that could cause a problem. But I don't know if it's that bad, because the principle is that we're using whatever best estimates of the value of a move we have at any given time. So I think it's okay. And some of that might be fixed by Quiescence Search, which we'll get to. Okay, so the search function looks okay. I don't know that it has to be changed. Oh, this is my new logic for the timing. I forgot. This is also new from last stream. I just set it so that the target is 50 moves. So let's see, did I do the math correctly? So first I have, right, so you get a time limit, which is how much time you have left. And so here I calculate an approximation of how many moves I think there are left in the game. And so I think there's going to be 50 moves in the game, just as a ballpark number for how long many chess games tend to be. So I say, 50 minus full board full move number. So that's that'll capture. I think that there's going to be. Yeah, so that's how many moves there are till we get to move 50, and then I don't let that go below 10, right? So if that's less than 10, like it could be negative, then we should say there's going to be 10 more moves in the game, and the target time is then the time limit divided by that number of moves. So we want to say on average we make we want to make enough moves so that we essentially end up with 0 seconds on the clock at the end, and then I divide by 1,000 to convert to seconds. So that's the timing. So I think I'm okay with this. I don't want to change that. I don't want to change. Yeah. So this is where I'm storing the positions that we actually visit. I think I'm okay with that. That's happening at the beginning. Right. That's showing the position after the opponent makes a move. So yeah, we want to do that. So this, and then here we have this is the iterative deepening logic, and so I want to keep that. So I make a configuration. This is ugly, so I want to adjust this somehow. And I think we're kind of at the point where the pruning's been helping, the caching has been helping, and the sorting has been helping. So I think I'm just going to remove this. So I'm going to make the first incision into the code, and I'm just going to get rid of that config object. So this is going to break all this stuff here, right? This is broken, and now we have to go and fix it. I do want the score function now to be, again, inside the class. So I guess I'm going to copy this minimax score and move it inside the class. And I'm going to get rid of this config object, so I'm just deleting that. So I'm going pretty aggressively into changing these things. These improved score and material count, I guess those can stay outside. I kind of want to remove improved score because I feel like this hack is not reliable. And there's all this hanging piece of stuff. This is all it's in a Git repository, so I'm going to be pretty aggressive about chopping stuff out. A lot of times I comment stuff out, but I think I just want it to be really, really clean and readable. Yeah, I mean, the improved score, let's get rid of it. I don't like it. At some point we'll think about, hand designing a score again. So, all right, so where am I? So I just moved the minimax. I had to paste it in before I lose it. I copied it, but I didn't paste it. So this is now minimax. It's now inside the main class. And let's change the what is this called? Function signature. Is that what it's called? So minimax score should get a board. That makes sense. Opponent best and my best, those are the alpha and beta. I might want to change the name of minimax score because this is technically negamax, the way I implemented it. Let's call it that. So current depth is fine. Cache, this is ugly. I'm gonna get rid of the cache because now I'm just gonna say cache is given by the parent. Right? This is now a member function of the score engine, and score engine has a cache object, a known positions object. Okay, so I'm gonna get rid of that. I'm not gonna have a config object anymore. And I'm just going to use this for the sort heuristic. I'm just going to get rid of it. I'm just going to always use that. I'm going to always make it the cache lookup. What do I call it? The cache score. Right? It's always going to be this. And while I'm at it, I'm going to get some documentation here. So compute the raw evaluation of a position, or use a cached megamax score if available. So, okay, and let's clean this up more. So negamax is now like this. So if there's a deadline, that we're still gonna have a deadline. We're using this global stuff for now. It's pretty ugly. I guess I could put it into the class, but I don't really want to do that either. And let's see, what else do I need to change? So instead of using sort heuristic here, I'm just gonna say self.cachedScore. And this is something to think about. I need to give it self to make it a proper class method. Okay. So this thing I want to think about. So I'm going to put a comment here so I can put write down in English what I'm thinking here. If we are at a terminal node, return the raw score or cached score. I mean, okay, maybe that text is not so useful, but the point is that there's something interesting here, which is that I'm asking it to return a cached score if one is available, which means that it can actually sort of look deeper than the maximum depth. Because if we're at a position that we visited previously at a lower, like a previous depth, then we kind of get to look ahead, which, I mean, it's the right thing to do, right? We always want to use the most. We want to use the most like informed score for any position. So that's what's happening here. All right. So now we're past the base case. So now we recursively reason about the best move. Here we create the best move. Okay, so we have a, wait, hold on. So we have a best move object, which is none. We have a best score. And then we generate the children. And here again, we don't need sort heuristic anymore. We're going to use self.cachescore. So we're always going to sort, config sort. So I'm going to get rid of the config sort stuff. I'm just always going to sort. I'm just going to condense this because it doesn't need so much white space now. Well, I think it, yeah, that's fine. And I'll just go like this. Okay, and this is what I wanted to do. This piece I want to be able to be configurable. So I just want to actually, what I want to do is replace this with, I'm going to cut this and I'm going to say children equals, let's call it generate children. Board moves. Okay, so I'm going to require that we give this function, oops, where I lost my place. This function has to receive something called GenerateChildren. And by default, it's going to be legal moves or sorted legal moves. I don't know what I call it. Let's call it get legal, get all moves. Okay, let's call it that. And we're going to define get all moves, and that gets, what did I give it, a board and a set of moves, and we're going to return children. All right, so the reason I do this is that it's going to return a scored list of I'm just thinking of if I should return the scored list or a sorted list. So the design question is, if we return a sorted list, we don't actually need you know, to return the scores. Sorry, if we return a sorted list, then we don't have to return the scores. But if we return the scored list, then you might be able to do something other than sorting them. All right, that's fine. Scored list of moves to consider to search over. Okay, so again, the reason I want to do this, not again, but I was getting to this. So I want to be able to do something different here. So for Quiescence Search, as I was saying, you're not going to search over all possible legal moves. You're only going to search over moves that are like, you know, very tactical, like moves that you can, where you're capturing a piece, or you're escaping check, or you're putting a king in check, which is a much smaller set of moves. And so I want to be able to sort of write another version of this that filters out all non-tactical moves. But for now, it's going to be to get all moves. So we have that here. Children is generate children and get the moves. And then here, then we loop over for every single child node. We will create a new board position and then evaluate it. So we do that by using our cache score. And then here there's a cache key. Okay, hold on. Why am I doing this caching? Does this need to be? Yeah, this is correct. So I need the self.known positions, and I'm gonna put a new line somewhere in here to make it easier to read. So I think maybe put it before the else. Nope. Okay, that won't work. I have to put it, let's put it here. Okay. So what this is gonna, yeah, so now we're just always, every time we use the cache, we're just gonna use this known positions object. And now this recursive call is broken because it's no longer called minimax score, it's called self.negamax, and it receives the bounds, the current depth, that's the cache, which it doesn't receive a cache anymore, it doesn't receive a config, it doesn't receive sort heuristic, it should receive the children. So let's call it, wait, let's make sure we have everything we need. So deadline, I should give it a deadline. Wait a second, have I not been passing down deadline? How did my code work before if I wasn't passing deadline? I mean, it doesn't really matter because I'm going to do it right now, but I thought, that's weird. Okay. Oh, wait. Yeah, because like here I'm not passing deadline to the next level. I'll have to look at the previous version on GitHub. But anyway, so here, if I pass it the board, the bounds, and the current depth, so I go board, bounds, current depth, and I want to give it deadline and generate children. So let's deadline, generate children. Okay, and then instead of cache, we call it self.knownPositions. Gets that. Cache hits +1. This is self.negamax. Now again, this was an issue of refactoring that I talked about before. Do I want to somehow combine this call with this call? Oh, this if is happening. Oh, you know, I'm getting rid of this. That's only if we're not caching, and now we're always caching. So that would be here. Oh, I see. It would be else. It would be else. Ah, shoot. Okay. Else. So so here are the two conditions. Deadline. If we're out of time, it's just going to return the cache score. If we're not out of time, we're gonna recurse. So we recursively call negamax on the next move, and then cache hits. Yeah, okay, this is fine. This is fine. Oops. Okay, score, and then again, let's think about this. If the score is greater than the best score, then we found a better scoring move than we have seen so far. So the best move becomes the move, best move score becomes score, and then my best gets updated. So that's the bound that gets updated. And then if we prune, so we are going to prune now. So no longer will we check if we're doing pruning. We're just going to always prune. And now we're saying if the score is greater than the opponent best, then we prune and we return the best score. I think it's fine. I'm going to get rid of this unused print statement. And then the last bit is if we don't prune, we just finish searching all the moves and we return the best score. Seems correct. There's this part's broken. So score function gets the board, the cache, which is not going to use anymore. And the config is not going to use anymore. It's going to be current depth. Aha. Did I just lose max depth? Yeah, this is a problem. Current depth config.max depth. This word config's not, so it's not. This is a result of me having code in the this global scope. So I have these config objects that the IDE is not telling me I'm wrong about. So I don't actually have a max depth. I'm accessing a config object that I don't actually have. So where am I? So this thing. When I call this, I have to give it a current depth. I have to give it a max depth. I don't need to give it a sort heuristic. I need to give it a deadline. Deadline. I need to give it so I give it a board, current depth, deadline, generate children. Time limit, ponder. Yeah, there's a little bit more tricky stuff happening. So I saw this config object. I'm getting rid of it now. Score function, let's get rid of that. I'm going to turn off this config. Let's just say max depth equals, let's just set it to 4. All right, so now the object, the class stores the max depth. And how do I look at max score? That's why is it not okay? Score. All right, here we go. Okay, so now I'm giving it board, so it's board, opponent best, and my best. Strange that I had it flipped. Oh no, I don't. Okay, my best. And then opponent best. All right, so current depth. So this is going to be cur depth plus 1. Let's see the next line. Deadline, we'll keep the same deadline, and then generate children, we'll keep the same generate children. I think that's it. Oh, yeah, I'm still missing max depth. All right, so now I have to change the prototype or the signature for this function. I'm losing my place. Okay, it is, oh, I was scrolled to the right, that's why. Okay, this thing we need to give it a maximum depth. So let's put it here. Again, I'll just give it a default just in case we forget it at some point. And the max depth will be 4. So okay, so now we pass that in after the current depth. So let's just put it here. So that doesn't change. And so now this, yeah, so now this is that's the recursive call. And again, yeah, we'll see if this runs after. All right, so I have that part. Now where I call it in search is a little messed up. So this score function and the ID is not really, it can't help me here because it doesn't know what score function is. But so I have to remember what it is. Let me just copy this because I think it's going to be very similar. Oh, you know what I could do? Wait, self.score function? Oh, I know. I don't want to change the score function. I want to just always use negamax. All right, so this is easier. So now we have the let's just do this. So we have new board, score, new board. Come on, give me the autocomplete. Okay, new board. We want opponent best. Let's leave that at its defaults. So we'll skip those two and we'll just say cur depth equals 1, max depth equals self.max depth. Okay, I see. I don't actually have to pass down max depth because it's in the current class. So I'm gonna change that. I have to remember to do it. So deadline equals deadline. I think that's an object I have. Generate children equals self.get all moves. All right, I think this will work, but well, no, it won't work yet. I have to fix a couple things. I have to go to negative max score. So I'm dropping max depth. I'm not going to use it. I'm not going to call it anymore because I'm sorry. I'm not going to request it in the function definition anymore because it's part of the class that we're in. So like here I use it, but where else do I use it? I guess I use it in here, so I don't need to pass that down. Oh, now the indentation's messed up. Okay, I'm getting closer. Yeah, refactoring is always like you're keeping track of a few things in your head, and if you forget one thing, then it might break. But then that's why we run it and test it. Another thing I should have done is I should have done a test. Like now that I broke the configs, I should have written the test first. Yeah, maybe I won't do it today, but at some point I do want to write actual unit tests for this. But since I'm not doing that, I'm going to modify this to get rid of these config things, and I'm just gonna run a score engine call. I'll just run it once. Set the time limit. It's fine, I guess. Let's see if it runs. Config. So somewhere I call config. So this is config max depth. So where am I? I'm in search. I don't want that. I'll just use self.max depth. I'm going to run it. And another config. Self.max depth seems fine. Okay, so now it's trying depth 1. Okay, I ran out of time at depth 1, so that's not great, but that's because I set the time limit to what? Why did that happen? Time limit was this. Oh, you know what? It's probably thinking that it's like move. Actually, I don't know what move it thinks it is. It probably thinks it's move 0, so it has to make. All right, let me just give it a lot more time. How did it take so much? Why did it take so much time to do one depth? Just a second. Okay, sorry. Okay, yeah, all right, I'll try running it again. I don't know why it was so slow. Yeah, so now it's, oh right, I forgot to read what it said. So right, it calculated some time limit, so this time it's trying to do it in 1,000 seconds. So it will run the full search. So again, one of the possibilities, if I remember correctly, I have my notes. Oh no, I don't have my notes. I have a notes notes file where I was showing the runs from previous settings. Yeah, so Oh, so it finished in 30 seconds. That's not so bad. So in my notes, I have that. Yeah, it took 29 seconds to run to depth 4. So yeah, it's running about the same speed. This is a different position than the one I tried here, I think, which is why we got a different. Well, no, it's the same position. So we got more cache hits, fewer prunes, and more positions that we looked at. So that's not good. Something changed. What changed? So this refactoring could have worked. It got the correct move. It finished in about the same amount of time, but it's the different statistics are. I mean, the statistics are different from before. So something is off. Why? What did I change? Oh, you know what? Iterative deepening. That's one thing I changed. I didn't do iterative deepening in this trial. So yeah, so that's probably all it is. Okay, so this kind of works. We might be at the point where I could actually try this Quiescence Search. Let's see. So the thinking behind the Quiescence Search is that rather than doing this, right? So what's happening in our logic, in our AI right now, is that when it runs down to the maximum depth, it just returns the best estimate of the score. And for the most part, when we reach this, it's just going to return the material count. So it's going to count the material, and it's not going to consider the fact that, like, if you have a queen, I mean, like something ridiculous, like if you have if you're in a position like this, am I in not in a, yeah, so like let's say I don't know, how do I force this position? So let's say I go like this, right? So in this position, what's the material count? It's even, so great. I mean, but obviously, I mean, if you know chess, this is like not a good position for white. So what Quiescence Search does is it will just check all the possible captures, and just keep doing that for another few depths. Ideally, we could even try to infinite depth. I'm trying to imagine a scenario where that could just like be too huge. I mean, it must sometimes become too huge. Like there's a situation, like there's two captures here. There's at least, so there's this, and this. So the two captures on the board are these two. Is there anything else? That can't capture anything. The queen can't capture anything. Yeah, so those are the two captures. Is there any checks that I'm missing? Yeah, there's this check here. So if you count the checks, there's that. So there's actually 4. 1, 2, 3, 4, 5. Wait, sorry, 4. 1, 2, 3, 4. There's 4 moves to consider, which is a lot less than what normally happens on a chessboard, right? Normally you have like all these moves. There's just a lot of moves to consider. But in Quiescence Search, you just look at the captures, and the naming. It's a word that's not very commonly used, but I looked it up. It's a quiescence is like the concept of quietness. Right? You're looking for a quiet position, and this is not considered a quiet position because there's moves under attack. Or sorry, no, there's pieces under attack. So I think we can just do this by, I'm just going to say, we're going to return, how do I spell this? Quiescence? That's not right. It's such a, I just don't know this word. It's not a word I commonly use. Let me look it up. I'm going to change it. So I'm going to look for, I'm just going to call it quiet position. Okay, so essentially this is running a whole new like recursive search at this maximum depth, but one with a much smaller branching factor. So ideally, it doesn't take too long, but we're gonna try it. So now we can define quiet position, and it gets a board object, and I don't think it needs anything else. I think what I'm going to do is I'm going to say return megamax score. So it gets board, it gets opponent best. Sorry, it doesn't get these things. It will just use the default for those. It'll use cur depth equals, I don't know, 1. I don't think it matters. Oh, you know what? This is a case where maybe I did want the max depth to be adjustable. Okay, I'm going to write a note. Because for now, this will reuse the current max depth. So it's just going to run to the current max depth. And that'll prevent it from blowing up. If you know, I don't want it to take infinite time. This should be self.megamax. And then, sorry, so the current depth is going to be 1, and deadline, I'm going to give it no deadline, because I wanted to spend time on this. I mean, my thinking is that we have this time management strategy, and this will allow the AI to spend more time in a complicated position if needed. Right? If it's a position with lots of tactics, we want it to spend time getting it right. So I'm going to give it no deadline, but again, we could change that later. Like if this makes it just time out, that's bad. We don't want that. Okay, the key difference is that GenerateChildren is going to be different. So let's just, whoops. Let's call it loud moves only. Okay, and I think that's all I need. I mean, I had to define loud moves only, but okay, so this is going to be something similar to get all moves. So I think I can just start by copying this board. Oh, okay. It gets moves, board moves. Is that right? Board and moves. Okay, so it's going to filter the moves, and this is where I have to go to the Python chess API. There's some tools in here, right? So I want to know. So I guess the point is that we're going to check a capture or check. We want two things. We want three things. We want captures, checks, and check evasions. So I think one way to do this is, so first let me do check evasion. So if I'm gonna do some formatting here, so I can say like I can say if board.isCheck. I think that's a command. I'm not sure, but and I'm going to do or. I'm going to say move. Okay, I'm just going to write this, and it's going to be incorrect, but like move is capture or move.isCheck. Okay, none of these are correct. Now let's find out. But this is the three things I want to represent. So now I go and figure out how do I actually implement checking if the board before the move or after the move has been undone is a check, or if there's a capture, or if the new move is a check. So let's try to figure out how to do those. So I think I can go to this all one page. Yeah. Okay. So I can just search for check. That's not a good word for me to search for because, well, it's not that bad. All right. So we have isCheck. So isCheck is a function of boards, I think. Okay, it's in chess.board. So I can check whether so isCheck tells me if the current side to move is in check. Yeah, so that sounds like what I want here. So this one looks good. Now this one, gives check. Here we go. Gives check. It probes if a given move would put the opponent in check. Well, I can do this. I feel like there's a little inefficiency here because I'm pushing the move on there. So actually, I think what I want to do is maybe put this if statement up here. So I don't want to push the move onto the board until I know if it's so inefficient, isn't it? All right, I have an idea. So then we're going to say this. I'm going to say was check. Was here. This is here. Was check equals that. So now we know if we were in check before we tried any of the moves, and now we're going to try the moves. So we're going to try each move. I think I want to move this down here. I want to move this up here, and then I can do if was check or if board.is check. All right, so let me just think about the logic here. So this is just for the checking logic, like chess checking, not logic checking. Okay, so first we see, is the board in check? If so, then we want to consider all moves, because there's only a few legal moves when the king's in check, and so we want to try all ways of evading or blocking that check. And then for every single legal move, okay, so if it's not check, this will evaluate if there's a check. For every move, we're going to try the move, and then if the new board is in check, that means that we moved in a way that checks the opponent king. And then the last piece is we want to check if there was a capture. That's tricky. So let me see. So if I just do this, first off, why is Python unhappy about this? I think I just have to, nope. Let's just do that. So I guess I had to do a backslash. All right, so then the last condition is whether there's a capture. So let's see if we can get that out of Python chess. Nope. Is capture. So it checks whether the given pseudo-legal move is a capture. Well, I can do it in one way. That's not my favorite way of doing this, but I can do... Wait, what? This is on the board object? Just capture... Yeah, it's in the board object, so I guess I would say board.isCapture move, and then I just say, well, now I feel silly putting it on 3 lines because they're all kind of short. So I'm going to say is capture, and I think that should work. So let's work through the logic, just make sure everything's correct. So we get a board position. We have a set of moves that we know are legal. We first check, is the player to move in check? That's this, was check. And then for every single move, we check whether that move is a capture. And then we make the move, and then we can evaluate whether we should consider this move. We should consider it if we were in check. We should consider it if we are now in check after making them. Sorry, if the opponent is now in check after we make the move, or if this was a capture. So I think that should work. I mean, there's going to be bugs, but that's what it should be. So now why is this complaining? So loud moves only. What's the problem? Unresolved reference. Did I spell it wrong? Oh, self dot. That's what it is. Okay. Okay. All right. And now I think what I'll do is I will do a little print statement so that we can see this. Starting Quiescence. That looks right. I shouldn't put it there. It doesn't go there. It goes, oops. It goes here. All right. I mean, I think that should work. Let's try it. So if I run it now, maximum recursion depth. So something blew up. Something blew up. Oh, I know why. Okay. Yeah, so I'm calling Quiescence Search, but then I'm saying, like, at the end of every negamax, you know, the base case is always do this. So we have to change this. We have to allow it to be, to have a different evaluation function. So we're just going to say evaluation function, and we're going to say, to give that as a parameter. And by default, we're going to say self.cachescore. That's the default. You can't do self. Tricky. Okay, well, I have a solution that's okay. So I'm just going to say, minimax, no, not minimax, material count. But I will now, when I call it in the search function, I'm going to say evaluation function is equal to self.cachescore, and the other time I call it is here, and here I'm going to say evaluation function. This time I'm just going to, oh, sorry, yeah, this is wrong. So I want this to be self.cachescore. The one down here, I want it to be confusing. Okay, so there's three places I call negamax score. One from within negamax score, which is this one right I'm looking at right now. There's one from the search function, and there's one from the quiescence score, or the quiet move search. So this I don't want. This I want to be self.quiet position. Okay, let me think about this. So again, from the top, we call the search function. The search function is going to call a negamax score function, but with the evaluation function being the quiet position search. So when it reaches its maximum depth, it's going to run now the quiet position search. The quiet position search, when it runs, will search but evaluate using CashScore, so that we shouldn't have this like double recursion. All right, I think I can run it. So yeah, this doesn't look great. It looks like it's probably still messed up. Although some of these could be that it's running Quiescence Search and it's finding that it's a quiet position, and so it's fine. It's in fact, probably what I should do is what happens if there's no legal moves? Or not legal moves. What happens when children is empty? So when I have this generate children, I don't think that my logic is correct. So I think I worked under the assumption that children will return something, a list of moves. But in Quiescence Search, sometimes you return a list of no moves because there are no captures, and that's a quiet position. So in that case, we should just return. I mean, one hack is I could just do an if there's, if children is empty, then just return this thing. But That doesn't feel great. But it does work. Really doesn't feel great though. All right. Let's just do it. So we're going to return self.cached_. No, we're going to return evaluation function. Yeah, I think that's correct. Quiescence score. I was so confident a minute ago of spelling it. Okay. So in terms of my printing, I don't really want to print if there's a quiet search. So I'm just going to say well, yeah, this is going to blow up because it's going to evaluate so many times. I have to think about this. The evaluation function is only called at this here and here. It's not, I better not be, I hope I'm not using it to sort. No, because the sorting is done here. Oh, shoot. Sort, so sort score is, yeah, cache score. So I'm not reusing the evaluation function. There should only be one, yeah, there should only be one call to Quiescence Search for each end node or terminal node. So let me just run it. So without the prints, let's just see if it gets the same move. Now, okay, the fact that it's taking a long time to do depth 1 tells me that Quiescence Search is running too long. So something's, I mean, I'm surprised by that because there's not that many captures coming out of, oh, are there a ton of captures? Maybe this is, I have to look at this position again. So I'm testing with this position. Let's look at it on the board. And I can do that, not here, I'll have to do it in, oops, come on, board editor. Let's type this in, analysis board. So let's say we're in depth 1, right? So it's black to move, so black can do anything. Right? There's so many different moves with this rook, for example. But now, given that the rook, let's say the rook moves here, now Quiescence Search will start running. So what are the different captures available to white? So in this case, white can capture there, white can capture here, here, here. It's a lot of captures. So let's say white does that, then black has to consider this capture, this check, which is part of the search as well. I guess that's it. But what's weird is I have it set to the maximum depth 4, so I feel like there's still a bug. How do I check this? So like I'm really close. All right, so we're looking at loud moves only. Is there, I mean, okay, just so we can see some of this, I'm just going to say found loud moves All right, so let's see how big these numbers are. 7, it's like one of them was 7, then it was 6. There's a bunch of 1s. Never seen any zeros. Why are there no zeros? Right, we should expect to see some zeros because some of these positions should be quiet. But oh, maybe at depth 1 there's just a lot of, yeah, at depth 1 there's just a lot of loud moves. Well, let's walk through the logic again to make sure. I mean, let me try a different thing. So if I just set this to an empty board, so it's just, whoops, well, that's not right. So we're just gonna set a new game. So there's nothing on the board yet. In this position, I think we should have a lot of quiet positions, right? Like nothing is an immediate captures. There's very few cases. Okay, so a bunch of zeros. There's some 1s and 2s. I guess if you open up the bishop, then sometimes the bishop can go out and just capture something. I mean, is that true? Let's try going. Let's do a new board. So like at depth 1, can you create a capture by? No, you can't. Like this bishop can't get out. Can't hit anything. I mean, if we're at depth 2, you can see something like this. I kind of don't believe the numbers I'm seeing. I feel like there should be a lot more zero. Well, I mean, there's a lot of zeros here. It'd be useful to be able to visualize this, but that takes a little bit more coding than I think I want to do at this stage to get the to visualize what positions the computer is considering. So if this is correct, right, this is really depth 1. It's trying depth 1. Depth 1, what does that mean? That means it's just making a single move. So this doesn't look right? It's making a single move, and somehow it's introducing multiple captures, multiple possible captures. So I guess here's what I'll do. Let's really dig into one of these. Where am I? So the children is here. So let's look at oops. Okay, so I'm gonna print the board. I'm gonna say that there's that many loud moves in that board. Let's get the Fen. All right, let's find one that has lots of loud moves and see if it's correct. So this one's two loud moves. I mean, this doesn't. I'm very surprised by this. Although this is like depth. Wait. Oh right, because Quiescence Search is going to go deeper. Well, okay, let's see. Let's examine this. So in this position, I can just type in here. But how do we get here? Or maybe I should print the PGN. That'll give us the previous moves. Oh, that's actually, there's no PGN. How do I get the PGN? PGN read game, PGN dot game, chess that no, print game. I don't know. Well, hold on. Is there any class going on? This isn't a class. This is just me messing around. There's a question about whether this is a class. Yeah, this is not a formal class. This is just me having fun. We're not. Yeah, I'm not going to be teaching an artificial intelligence class for a while, but I've taught this kind of class in the past, and this is like, I guess you can view this like chess programming as like a much more complicated version of like the homework that we give in those classes. I don't know if that was what you were asking. You could have been asking about Python classes, which I'm building one of. But anyway, so all right. So just looking at this Fen, like how could we have gotten to the position we were in? So just working backwards, I mean, it looks like white was, white went here, black went here, white went here, black went there. I guess that's where we are. So none of those should have happened in Quiescence Search. Like depth 1 search and Quiescence Search should not have done that. So depth 1 maybe should have considered this. That's fine, right? How do I clear these arrows? But that's fine. Like that move is correct. I mean, we should be considered. But then at that point, Quiescence Search should find nothing. But for some reason, it chose to try these other things. So I'm going to check. Yeah, something's definitely wrong with the code or with the implementation of the algorithm. So after doing loud moves only, it's as if it returned more than it should have. But it only found, a lot of times it found 0 loud moves, and that's good. Quiet position, GenerateChildren, loud moves only. Children equals GenerateChildren, board moves. Tricky. Quiet position gets the board. Yeah, I mean, I was a little ambitious to try for this today, but because I did the refactoring and that's fine, but now I added this Quiescence Search that's not functioning correctly yet. But I feel like I'm really close. I feel like there's just like a minor bug, and then it'll do some nice things like avoid hanging pieces. Okay, so what could cause this to happen? Let's look at another one of these positions. So I'll just run again the PGN. Let's just do Fen. Oops. So here's one. There's one loud move here. Well, actually, I think this was one where there were 2 loud moves, and in that case, it's white to move, so white can capture here and there, and that's it. And that looks correct. But let's look at this one. So this is all right. So it says it found 1 loud move. So is there 1 capture? Whose turn is it? It's white to move. So yeah, this is the 1 capture. So that looks correct. So I think this like generate loud moves thing is working correctly. So it's how it's being used that's not correct. And we're calling it from NegaMaxScore. So the NegaMax algorithm, it's checking, it checks if there's an outcome to the game, and then if it checks if it's at a terminal depth, and if it is, then it will just evaluate and in that case it will calls cached score, which is good. And then the children, then it generates children from the list of legal moves, so that'll filter the legal moves. And the evaluation function, right, so if there's no legal moves, it will return the evaluation function, which again will be cached score, which is also what we want. But then if not, then it goes into other moves. So I mean, I guess I'll do this kind of debugging. So let's see. Oh, you know what? This is going to be really messy because I want to only do, oh, I know. The trick will be for me to debug here, and only when it outputs that it found, okay, it found 2 loud moves. So now that it found 2 loud moves, I will now take a couple steps in the debugger. I guess what I want to do is I want to get out of here to see the loud moves. Okay. I don't know how much. I don't know how this helps. Yeah, it's not gonna help. It's too complicated. So how else can we try to drill down to what's really going wrong here? I mean, I'm pretty sure this is not correct. So what about this recursive call? Is this doing the right thing? It's still gonna, it's gonna use the same evaluation function and the same GenerateChildren call, which should be correct. Alright, since I'm slightly confident in the spelling, we got Quiescence. Oh no, I'm now losing it. Does that look right? No, Quiescence? No. Alright, I'm just gonna look it up. Quiescence Search. Let's let Google fill in whatever I wrote. Okay, Quies. Okay. Let's just refactor that. Okay. All right. So we're still in depth 1. So in depth 1, somehow we get to, I mean, you can see these numbers are the number of moves. So somehow we got to, let's try to trace through this. So first it looks at this position. This is depth 1. I mean, sorry, this is part of a depth 1 search. And again, it got there. How did it get that far into in depth 1? Like that's clearly 1, 2, 3 steps in. I mean, is that a problem with the main minimax, the Negamax algorithm? So I have it as going, you know, it starts at depth 1, and its maximum depth is supposed to be also 1 to begin with. Oops. Okay. I mean, for sure, it's at this point we now know it's gone deeper than it should, which might also explain why it's a little slower than I expected it to be, but it doesn't explain why it's bad at chess, right? Like if it was really going deeper than I intended, then it would be slower, but it might be making better moves. But that's not really what we're seeing. Let's do debugging here. All right, so we've hit this point. The current depth is 4. How do we get to depth 4? I thought we were starting with depth 1. Yeah, there's definitely a bug. This not related to the. It's not related to the Quiescence Search right now. It's just that this Negamax score, I'm not giving it a maximum depth. That's the problem. That's the problem. This is, yeah, that's right. This. Oh, it's supposed to use I know. Okay, I got it. I have right now calling this, you know, I'm saying the maximum depth is, I'm just using the thing passed in by the thing stored in the class. I'm using the value stored in the class object, but that's not what I want. I actually want to be able to use a smaller depth than this. That's how the iterative deepening works. So I'm actually going to have to turn off, you know, not use self.max depth, and instead pass that in. And I guess I'll inject it here. So by default, you'll use the self value. Oh, you can't do that in Python. All right, I'll just set it to 4 then. That's fine. We're not gonna run it with the default. Okay, so now every time I call Negamax score, I have to give it a max depth, and I also have to watch out for. Yeah, that should be depth of score. Yeah, that's right. New depth, cache depth seems fine, and then here current depth, and now we go to max depth. Okay, where else does depth come in? Okay, so depth doesn't. Okay, that's it for inside Negamax. And now for in here, we get to pass in the max depth equals depth. All right, let's leave it like that. A little ugly, but okay. So this depth is the thing we're iteratively growing. So now we should really do depth 1, and then we should see lots of zeros in the Quiescence Search, I think. Let's try it. Okay, slow down. All right. So from the beginning, right, we try all these moves. We see 0 loud moves. That's good. Let's see. Let's just check. Yeah, so here there's no loud moves. No captures. No checks. That's fine. That's what we want. Now, where's the first time we see a loud move? Here. This is the first time there's a loud. Hold on. Wait. Let's just clean this up. So So here, I'll just say if children. All right, so we're only going to do a print when we have allowed moves, and then that way we can look at some positions. Okay, the very first position where we see allowed move is after depth 2. Good. So let's see if this is correct. So maybe this is actually working. It's just slow. That's good/bad. Yeah, so in this position, white has allowed move. It can capture. That is correct. What about here? Yeah, similar situation. Here, just one more just to see it. Yeah, like similar again. Now, again, those are only one. And what's cool is that we see it quickly moves on to the next thing because it does a search and probably is able to evaluate it quickly. Or actually, you know what? If we were going deeper in the Quiescence Search, we would see in the next time that it prints this that it would be further down that chest line. So let's look for. Okay, so here's a too loud move position. Let's make sure that this looks like how we expect it to. Again, wait, whose turn is this? This is white to move. There's the queen captures. These two queen captures, they look really bad, but they need to be considered. So it seems to be working. So why don't we turn off this printing and see if it ever finishes. So yeah, it's going through depth 1, 2, and 3 pretty fast, which is what we want. So that fixed that bug before. Now, is it still a 30-second? I mean, we were talking 30 seconds to get to finish depth 4 before. Oh, you know what? That was for a different position. This is for now a position with basically no loud moves, or starting from the beginning rather. So it might take a while, but this is also informative, right? So as you go to depth 3, we found that every move is score 4. There's 20 moves, 15 moves, 20 moves with score 4, score 0. And it's because you're coming out of the opening, there's no captures, very few captures, or if there are captures, it's often a fair trade. So the material advantage is very limited at the beginning. It's taking a while to calculate depth 4. That could be okay. I mean, I might be paying a lot with this Quiescence Search because it's not well pruned. There's all this, if you read chess programming, the chess programming wiki, it explains a lot of tricks people have used throughout the years to make Quiescence Search faster. And I'm not really using any of those tricks. I'm just using alpha beta pruning, which I think is correct to do, but it creates a weird situation. And we're also limiting that to depth 4. Oh, so finished. Okay, so it took, a minute and a half, and then it pushes the beep on. Okay, that's. But yeah, also informative. At depth 4, all the best moves are score 0. So there's no advantage to any move over any other move. Which we know as humans, we know that there are better opening moves than others. Not really, actually, but they're preferred ones. They're preferred ones over others. But maybe to a computer, a perfect engine might actually consider every possible opening move equally good. Maybe not the second move, but the first move, it could be that they're equally good. That's an interesting question. I'm not sure what the current thinking is on that. But to humans, we don't like certain moves. Like we like to control the center. We like to try to get our pieces developed. We don't want. I think like some of these weird non-standard moves, like make the position extremely sharp, and so a computer that can perfectly look ahead might be able to play it so it's even. But okay, so this appears to be working. The Quiescence Search is going to add some time. So I guess I'm curious how long it takes, how much extra time it takes. So we can actually, let's just try playing a game against this bot. So I guess I'll just check it in. I'll commit it to my repository, and so refactored a bit and added a prototype for Quiescence Search. Yeah, there's a to-do. That's fine. I've had lots of to-dos. What is the to-do? What did I put here? Oh, so there's this refactoring, and there's this. Yeah. So right now the Quiescence Search is searching to the current maximum depth, which I think I was set to be 4. That's a good question. What did I set it to? So this class now gets maximum depth 4. It's just set to that. I don't have anything that changes that. Yeah, let's just play at depth 4. I mean, depth 4 with Quiescence Search might be pretty powerful. Oh, I have to turn on the bot, so I'll run this script. And let's play Stockfish. So let's do a real time. I'll do a rapid time, the maximum time for rapid, and let's play strength 3. I think it gets destroyed by strength 4. 3 is going to be competitive, not with rapid time, but we'll see. All right, so we'll play this game and then I'll end the stream because I gotta go. What's happening? Let me try again. Okay, let's play again. 1510, random side. Okay, here we go. Yeah, so we're playing as white. I think that the opening move is limited to 10 seconds for some reason. I think that's an artifact of the Lichess bot API. And oh no, that's not a good opening move. But let's see. Let's see if it recovers. And I can actually look at the print of the script, the output of the. This is the output down here. So we ran out of time at depth 4. All the moves are equally bad right now. He's trying to make it move in 18 seconds. This is not looking good for BertBot. Objectively or not objectively, as a human looking at the position, it looks quite bad. So these are again the random moves at the beginning. So at some point, it's probably worth coming up with a different strategy for the opening. Oh no, it moved the knight, it undeveloped the knight. I think what we'll see, we'll probably see whether the engine's working at all when we get into tactical positions. Okay, that's not a great move, but again, it thinks the score's 2? I don't know. Is something just completely broken? Again, I don't know if this is just that the opening is just, you know, you have to look ahead too much to actually see any material advantage. And at this point, I would hope it's starting to see some actual moves. Would that involve material changes? Oops. Did it stop printing? It seemed to have stopped printing for some reason. Not sure why. That's okay. We can still just look at the game and try to understand what's happening. I mean, it's just pushing that pawn, which I really don't think I don't think that's a good move. I don't see that it's justified. So I could, you know, previously I had this evaluation function where like I was hand designing a way of measuring how much space that was under control by each color. We could try that again. We could try to do things like piece coordination. Right now there's very bad piece coordination. White has basically none. But good opening, you want to have that. Calculating king safety is pretty difficult. You could also hard code development, say like, you want to move all your pieces off the back rank. That could be something else you could add in. So like different strategies during the opening might be worth exploring. So, well, nothing's printing out that's useful anymore. I don't know why it's erratically printing. So let's just watch the game. All right, so I made a threat. That's good. That's not good. Yeah, that's a good question. One question I have is like, how do we know if this is actually working, or like, is it not searching deep enough, or is it just, is there a mistake that I'm making in the code? There might be some position where we can see an obvious move, and if it doesn't see it, if the bot doesn't see it, then we know something's wrong. But these are positions here that it's not so obvious that anything is. I mean, Quiescence Search must be doing work here, right? So it's can I draw on this? Yeah. So like that. Oh, we made a capture. But like that move that capture was available to it before. And I guess so was the pawn capture that just happened. So there was a pawn exchange. That's interesting, I guess. Seemed like a reasonable. I mean, it seemed like a reasonable move, except for the fact that now the king is wide open. So that's not good. I don't know if the bot has a plan for if it gets under attack there. I doubt it does. Yeah, it just dropped a piece. So that looks like something's wrong, right? That looks like something's wrong. I don't see how. We can just go back for a minute. I mean, is it going to take back? No, it didn't. It didn't take back. So it could have taken. It could have taken here, but it didn't. So this really looks like something's wrong. So there must be a bug in my code. I mean, now it took back. Okay. But I don't know. I don't believe that it's hard to believe that it's that those are actually calculated moves. I mean, materially we're even for now. I mean, you could argue that's trying to kick the bishop out. Engine's working hard. Question is it doing anything useful? I mean, the move didn't do anything, but I mean, is it threatening an X-ray? I don't know. Doesn't seem like that actually works. But does it look like it works to an engine that can only search to approximately depth 3 plus Quiescence Search? Maybe. Yeah, I mean, it pulled off the discovered attack. But will that pay off? Whoa. Okay. Nope. Okay. Yeah, I'll have to think about what to do next. I think there's definitely still some debugging to do. I could look at some more puzzle positions and see if we can figure out the puzzle positions. Well, now that pawn looks in danger, how do you defend this? I guess you move the bishop away. Something like this. I mean, this position looks really bad for black, but again, material-wise, it's technically even. I don't see why. What? Wait, that was so weird. It moved so fast. Was there a checkmate? Let's see if we have any printout from the the code. It keeps running out of time at depth 2. Depth 2. Let's try to make the move in 25 seconds. I don't know. Computers, I mean, BirdBot is saying that the score is -1, so we're down a pawn supposedly. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, so could it actually have calculated that we're down a pawn based on position, not on actual material? I'm seeing that. Could be pretty good. I don't know how to take advantage of it though. Okay. Well, that just dropped a knight, didn't it? What just happened? Oh, it took a pawn, so they got 2 pawns for the knight. And it can get another pawn back right now if it sees it. So every now and then it's making a really fast move, which is kind of weird. Because it can't be that it searched to its maximum depth. That's just impossible. So it could be that there's not that many moves available in some of these positions. I mean, you know, this knight is creating back rank problems, so maybe there were some positions where there was like a forced checkmate coming, and so then it quickly searches all the possibilities. Or it could have just been I don't know, some weird bug with timing. Because I wanted to take advantage of the time that I give it, because the more, you know, the more time it takes. Wait, what just happened? I looked away for a second. Oh, so we're even on material again. But, you know, where, right, it's these 3 pawns. You have these 3 pawns. I mean, and then again, to a human, this looks ridiculous, right? Like, oh, look at how many great pawns we have, but they're all isolated. Like, there's doubled pawns here. There's this isolated pawn. This you would, I mean, this is technically not an isolated pun, but I mean, it really feels pretty isolated. So yeah, this rook is now trapped. So can we save it? I don't see how, but we could maybe counterattack somewhere. Looking pretty bad for us, but I don't know. The fact that materials even sort of suggest that this is working. Yeah, that's that counterattack I was thinking. So doesn't work. Okay. Yeah, that's pretty bad. So it's working, but it's not good at chess, right? Like it's doing what it's supposed to do, but it's not good at chess. Yeah, one of the things you see like with Stockfish on the lower levels is that it will just drop pieces. And we should have seen that, and ideally my bot would take advantage of it, but I didn't see that happen yet. And my bot has sort of done that a little bit, but I mean, should it take back here? It doesn't take back. Why not? I mean, it looks a little risky. I can understand, but I mean, it doesn't understand the value of this pass pawn. That seems like, at least in a human game, like if this were blitz, you just want to push that and put pressure on. But Stockfish has 17 minutes to calculate, so I don't think any tricks will work. Yeah, again, the bot made such a fast move here. This queen move, didn't make any. I don't see why it was such a obvious move to it, which makes me think something's wrong. I mean, one way it can be fast is if the caching, like the pruning, quickly identifies that other moves are not good. But that sort of would only happen if this queen move was a really, really super good move. But I don't see that it's. I don't think it's that good. It's looking pretty bad now. I mean, it was looking bad early on too, but it does take some pretty long-term look ahead to understand that pawn structure, like bad pawn structure, will cause you problems in the end game. Which, you know, I guess maybe we could argue we're approaching the end game, but well, I guess we are in the sense that we're about to get checkmated, but it's not. You could. I mean, the queens are on the board, so this might not be considered an end game, but yeah, I mean, it's definitely. What isn't this a mate in two? No, it's not. It's so we can block, or we can block the take, then we can dodge. Okay, I didn't see that. Okay, now what? It's nothing. Okay, well, yeah, it's weird. I really think that this bot was on purely just, you know, level 4 searching or depth 4 searching with pruning. I'm pretty sure it was beating Stockfish level 3 consistently, and I added all this extra stuff, and now it doesn't work, or it doesn't beat Stockfish. I mean, this is mate in 1. Why Stockfish? Wait, what did I miss here? wasn't this a mate in 1? Why is this not checkmate? Is Stockfish actually playing, like messing with us? I mean, it's still gonna be mate in 1. I mean, it's mate in 1 still, right? Like, no matter what we do, or we have one legal move. Why is this taking so long to search? So here, that's checkmate. Am I missing something? This is really bizarre, right? Like, at first I was, looking at our bot and thinking, oh, our bot is terrible. It can't find these obvious moves, but now it looks like it's Stockfish is also making some really weird moves. I mean, technically not losing moves, right? Because we're still going to be checkmated in guaranteed fashion, but okay. Well, so as we wait for this to finish, I'll just wrap up. Yeah. So I did some the refactoring. The code is refactored, but I don't think it's bug free, because I'm not so sure if this is actually how the code's supposed to be running. Okay, if you don't, okay, thank you. All right, good. Okay, yeah, it was weird. This is a weird game. I mean, it wasn't that weird because it's sort of like a normal game for a bad bot, but I thought the bot was doing better. There was a couple things I noticed in this printout where we're seeing like, we're seeing things like it runs out of time at depth, runs out of time, searching, trying depth 4, ran out of time at depth 4. I mean, that's fine. That's what we want. Yeah, ran out of time at depth 4. I guess if I let it go to fully depth 4, maybe we'll do better, but it's just weird. It really played weird. So I feel like there's some bugs, but we'll figure it out. All right, next time we'll figure it out. All right, I'm going to sign off. Thanks for watching. I hope you enjoy the video. It's kind of like just like a leave it on and, think along if you want, or not, just hang out. All right, till next time.